Thanks a lot. Super excited to be here in Denver. And yeah, let's jump in. So kind of starting high level, right? We want to make sure that web is not controlled by a few entities in the world and kind of return back to the state where the internet was centralized. So let's do it again. Now, just kind of about this evening, right? We'll talk about NEAR protocol, where are we today as like ecosystem in general, and kind of do a walkthrough and demo. And if people want to follow up and start hacking on this, that would be super welcome. That is the wrong slide. So just kind of a little bit about me. So I'm a co-founder and CTO at NEAR. Before that, I was working for 10 years in machine learning. So I was kind of on the dark side, collecting data, doing all the machine learning stuff. Specifically, I worked at Google doing research. We were figuring out how to use all this data to do all kinds of interesting things. But I was always kind of targeting knowledge part, so we were working on question answering. So if you ask a question at Google, I'll respond to that. And I worked a lot on developer experience for machine learning. Specifically, if you know TensorFlow, which is one of the major frameworks, I worked on all the APIs pretty much that you're using there. And that's kind of how, as we're discussing where to go with the startup, like blockchain seemed like a great place where the scaling of that we've done, both my co-founder and I, for different projects, as well as developer experience that we worked on before, kind of come together and realize that blockchain really needs this kind of stuff. So what is NEAR protocol, right? So first of all, it's a layer 1 solution. And let me get like a show of hands first of all. Who's familiar with Ethereum in general? Okay. Who's developer? All right, next. So yeah, so how are you satisfied with developing an Ethereum? All right. So what we're trying to do is, first of all, make it really, really developer friendly. Right? We want to make sure that as a developer, you can just come in, start building stuff. Don't need to learn new things, new concepts. You can kind of on-ramp over time about all of the specifics and like learn what kind of new primitives you have. But you should be able to build your first app within 15 minutes. And then on the other side, there's of course like if your app is successful, it shouldn't be that you bring the whole network down, right? And that your users need to pay like hundreds of dollars to use it. So of course, scale is kind of part of the developer friendliness pretty much. And if you think of it as a developer, what you really care about is users, right? You want to build something that people will use. And right now, it's like current platforms are kind of fighting with it. They're like, well, you should make sure your users install all this stuff, make sure they do this flow, make sure they go to Coinbase, to a centralized service, get some coins. So we're trying to figure out how to make this experience actually nice for users as well. And I'll show you some examples of what we're working on. But high level, this is all still like an experiment, of course. So any feedback is always welcome. So kind of just super high level details. So it's a proof of stake model. So no trees are burned, which is nice. And what this means is there's a number of validators that can own some coin, and they can say, hey, I want to participate and pretty much provide compute for this platform. So the way we like to describe it is it's a co-op cloud. Community operated cloud, where community comes in and runs the nodes, and this way you kind of break it out of the cloud provider. Specifically, we use threshold and proof of stake, which what it allows to do is kind of get as many people as possible participating in this process. So threshold here means that the price that you need to pay to become a validator, or not to pay but at stake, is actually determined depending on the demand of the network. Depending on how many validators needed, and depending on how many are participating. So if you're familiar with what, for example, Ethereum 2.0 is doing, they have this 32B's magical constant, which is, just kidding. I don't actually know where it came from. Here, this actually determines based on demand and supply. So the second thing, we're using a consensus, which is a BFT consensus, so presenting fault tolerant, which one important thing that allows us to do is actually not to have forks if that network operates correctly. Right? If there's no malicious actors, or number of malicious actors is below 1/3 in each shard, then the network doesn't fork. Which means you can actually, by looking at the block, right away determine if it's a final block or not, which makes your process way faster, right? You don't need to wait for 6 blocks or an hour or whatever. And what this allows to do when we go to sharding, when we go to scale, is actually be able to reroute calls from one shard to another really fast. Again, contrasting with a lot of other solutions, if you do have forks on these chains, you need to wait until you have some kind of finalization procedure. So Ethereum, for example, has a Casper FFG running, which pretty much finalizes the block, and only after that you can pretty much reroute something to another shard. So all of it is just making this kind of speed and finality really fast. It still will be seconds because we're still writing consensus. It takes time to have latency, but it's not going to be minutes like in other suggested systems. And the other big part of it is actually switching to WebAssembly runtime. So if you guys build on Ethereum before, you're using the Solidity language, which compiles to EVM. EVM is actually or at least current implementations of EVM are relatively slow because it wasn't really designed with speed in mind. And WebAssembly is the platform that pretty much was built to run code across all kinds of platforms, to be performant, supported by huge players in this game, and more and more systems are actually switching to it, right? Gavin Good is pretty much super huge fan of WebAssembly, using it for everything, including running the runtime itself on the blockchain. And of course, Ethereum, for example, wants to switch to it too. There's a group working on that as well. So let's answer the question why, right? Why are we building on this? And the answer is that right now, the people who are here, the people who are hacking in hackathons, we're early innovators, right? We came in, this is exciting, let's build on this. We have technical skills, but we have very high tolerance to pain. Yes, I'll install this, I'll click, yes, I'll go there, I'll take a picture, I'll dance in front of the camera to get the KYC done. But if we want to get to even early adopters, and I'm not even talking about actual mainstream people, right? And think of doctors, teachers, etc., right? We need to make this really easy to use and easy to, and it's the same on developer side, really easy to build. So the way we're kind of thinking of this is there's two arcs, right? There's demand, which is what do people actually want, how they want to use it, and there's a supply, which is if you do use this for, can you actually use it? Is there scalability there? So on demand side, right, as I mentioned, there's developer experience. New languages, new paradigms, this is just the barrier to entry. People need to learn, people need to kind of have a ramp-up period. If you're thinking hey, I'm gonna go to this hackathon on the weekend, right, it sounds cool, and you come by well, okay, so where do I start? And well, here's a blog post somewhere that describes you, but it's really old version because there's 2 versions out, and you have to try to put things together. There's all those tools that don't work with each other. And then on the other side, as a user, right, you go to CryptoKitties website, it's hey, you install the MetaMask. You're okay, so what is that? And then, okay, you install MetaMask, say, well, you need to now get some money to this thing because you cannot actually submit a single transaction. So, we talked to some of these folks, and they say, well, our drop-off rate of users who get to our web page is 97%. So it doesn't matter what kind of marketing you have. If you have 97% drop-off on a sign-up, you will not hit any large numbers of usages. And the other thing is if you think of developers, right, as hackers, you start kind of hacking, it's fun, there's some just kind of intellectual curiosity, but then as you kind of go into more entrepreneurial mode, you actually want to build a business out of it, right? You want to make sure this actually has some future. And ICOs was a huge craze. Everybody thought this is the solution, right? We now we can raise money, we can make this system pay for itself, and it will operate. But in reality, ICOs have pretty much the utility of the token is pretty much zero because well, utility is not zero, but the value of tokens that the utility inside the smart contract is pretty much zero because of infinite velocity, right? You can imagine an app where you need to pay for something. And there's this example about my video called Lemon Coin. You should Google that. But the point is, like, this lemon stand will only sell lemonade for lemon coin. And you're like, well, what's lemon coin? You're like, well, you need to go to Coinbase, buy some Bitcoin, then go to exchange it to lemon coin, and then you can. It's like, okay, that's, doesn't make much sense. So what is actually like a business model that is native to this platform? I'll talk about it a little bit. So what we the way we're solving it, right, is pretty much by making all those things, like have a specific solution. So first of all, we are using TypeScript as a main programming language you can build contracts with. You can still use C++ and Rust, but I don't know how to tell you guys, but even though I've been rewriting C++ for 7 years probably, I still don't want to write it. So TypeScript is just a JavaScript with types. It's really easy to write. There's a lot of tooling about it. You can actually start like using regular tools that if you've been doing JavaScript, you're already familiar with, or there's a lot of documentation for. Pretty much building the tooling system together. So like just a simple thing, continuous integration for all the tools, making sure they all work together. There's no like, hey, there's some version tingling there. And then building the community, right? Like there's a huge thing, making sure that there's materials, there's documentation, there's tutorials that are up to date, okay? Always available. So on the user experience side, a lot of things we did is actually change how accounts work. Specifically, accounts are not keyed by your public key, but instead they're keyed by some username or anything you want within some limit. And then you have public keys on this account. What this allows to do is the application can create an account on your behalf. And then when you want it, it can swap the keys. So you have access to it and the application doesn't. So this already allows, you go to CryptoKitties, you click a button and create the account for you on the blockchain. And you don't really care at this point because you don't really have anything in it. So they can load up some CryptoKitties in it, give you some, experience to play with them. And then when you care, you can actually go through the process and buy the account, right? Like check it out. It's kind of like this cart model, like in e-commerce. The other part is if you are holding tokens, there's actually like a underlying system, which is like because we have inflation in the system, you're actually losing a little bit all the time you're holding tokens. So this actually can pay for some portion of the transaction fees that you have, right? So if you already have some money in the account, this like pretty much generates some amount of network fees, right? Credits that you can use for transactions, right? If you go over that, of course, you still need to pay, but you have some, free network credits to kind of start using this. And of course, like apps should be able to because they can control your account, they can also just stake on your account and say, hey, I'll give you ability to use this app for this much, for this, this many transactions per day, as kind of a super. And this account model also allows you to do is not need to pass private key between devices, right? Right now, I don't know about you, but I'm pretty sure a lot of people have their private key somewhere in email or somewhere like in chat, and you just can exchange it between devices and not be typed. So this allows to pretty much another device just send the authorization thing to the device that already has keys, and this device can just add this new public key to the account. Now, two devices have two different keys, they put key pairs to access this account for different devices. So, going further, you can have actually different access permissions of these different keys and have different, you can give. This is access keys that only can spend $5 a day. This is access keys that can use this. If you want to spend all the money, you need 5 signatures or 5 keys. You can customize how this account is used. This is just making it really easy kind of for people to onboard from here. And of course, business models, right? There's a SaaS model which, it's kind of counterintuitive when you think of decentralization because you kind of don't want to. You want to pay per usage, right? These the logic of the current system is like pay per usage, not pay like a fixed fee. But the reality is it's really simple like models that people really like. Like you actually just want to subscribe once and not do it. So making that simple. And but the other part is you can still pay per usage, and then just developers can pretty much say if they want to charge an additional fee on top of the gas fee that the application runs to kind of get the rebate for the stuff, right? So application itself can define their own business model on a fee-based layer, right, as you deploy this application. Which kind of like what, in a way, the ICOs were trying to do, but we think like on layer one, actually building it natively is the solution to this problem. So on the other side, the supply, right? Like, do we have a scale to actually build these things, right? Like, let's imagine we take one of the top 10 consumer apps on the App Store, and have 100 million active monthly users, which, if you average it out, you can think of like 3,000 transactions per second. And this is taking like how many transactions per second CryptoKitties have as their current daily actives. So this requires, more than 10,000 transactions per second. So this is just like, if you want to take one of the popular game and put their, let's say like League of Legends, right? Let's take League of Legends and put all of their skins and hats and whatnot on the blockchain. So people can freely trade them, and League of Legends makes money off that trade through some fees. Well, this will just crash any network, like including even the OS, which like is pretty much centralized and the fastest currently. So, we need to solve this problem if we want any of these applications to actually start adopting this platform, even for smaller things, like even for this kind of centralized exchange of assets. So, obviously, like, there's a lot of solutions which are just improving a little bit, like there's like 5-10x, like just switching to WASM already would speed up the network. But all of this is a constant scale, right? You cannot actually grow the speed as your network increases. So the idea is that we need sharding, where the more nodes we have in the system, the more performance we can do in the network. And it's kind of natural if you think of it. As we get more nodes, we will get more throughput, right? There are more people who want to use this network, so you need to kind of grow with its size. So, pretty much, as I mentioned before, threshold proof of stake, TXFlow, or Nightshade, the new version of it, and sharding is kind of solving the scalability, and then on the other side, user experience and developer experience solves through WASM and TypeScript, context-based accounts, and hiding fees. So where are we at right now, right? We are released, and this is not today, DevNet. So DevNet is pretty much right now a node that you can run on your local machine. We have it hosted as well, and you can interact with our network. So this is runtime. Pretty much, if you think like Ganache or just running an Ethereum node locally, like a parity node is a new chain stack, pretty much this is it. And then from there, we're planning to have AlphaNet. So we have a version, it's all open source on GitHub. You can try running it. I don't recommend it, but we're gonna be like stabilizing it within a few weeks. That will be AlphaNet, where we can actually run like multiple nodes with consensus. And then BetaNet will add the actual economy that I was talking about. Testnet will add pretty much governance to it, which would allow some of the update process to be like way smoother. And then MainNet is when this actually becomes a currency and preserves state across the network. And from there, we're going to keep developing it. So one thing we want to emphasize is we don't believe in like, hey, here's a solution, here's white paper, here's a solution to all the problems. We're going to build it, deploy it, and be gone. We believe that this is like evolution, right? Like there's more and more technologies coming in. There's a lot of research being done on zero knowledge, on different types of encryption, different types of curves. Like all of those things can be built into this as we go, right? And there's a point to keep developing this, to keep improving this. So that's kind of MainNet is just one point in the process. So yeah, so just to set some expectations, we are more on the hello world side than on crazy user interfaces yet. So to kind of start more about like how does this all work together, right? So first of all, we did rebuild or like rethought how virtual machine work, because if you build for Ethereum, right, you're kind of building this class, right, that pretty much explains all your program, you have functions, and this class contains fields that are memory mapped to the state. Now, we believe this is kind of like, first of all, implementation-wise, it has a lot of problems, like the paging in memory. There's a lot of kind of small details that are weird. But as a developer, if you build something for Web 2, when you come into this world, you kind of like at loss, because it's not how you used to do, right? Usually you build a pretty much stateless backend and you have a database, right? And that's how we're modeling this as well. So we have a WebAssembly that runs your code, which is stateless, and you have a key value storage provided to you, just API for storing and getting values and deleting and searching. And pretty much through this, you can actually build like very similar to how would you build on Node.js, right? You just write your functions that accept the requests. You look up things in your key value storage. You do some logic. You store stuff in key value storage. You return the value. And I'll show you some examples how all this works together. So the other side of this is we are a sharded system, right? Which means you cannot actually call other contracts directly. Like if you think right now in Ethereum, you call the other contract, it returns a result. You maybe call another contract, it returns a result. If something failed in any of this process, you kind of fail the whole thing and revert everything you changed. Now, if the other contracts run other shards, you actually need this transaction to finish before you can start the new transaction on the other shard to execute the other contract. And the way to solve this kind of is pretty much to do asynchronous calls. So if you think of, again, Web 2 world, REST APIs is pretty much that, right? You have multiple services, usually microservices, that send each other REST APIs, and they don't have actually like state themselves, but they have callbacks where you call a function, and then when it returns back, you have some callback that you execute based on the deciding something. So that's pretty much what we implemented here, and like you can think of this as a mailbox system, right? Where each contract has its own mailbox, where pretty much requests from other contracts come in and you process them, and you can send pretty much mail to other contracts and they'll process it. And you can attach callbacks which says, hey, when I'm booking a hotel, if it fails, come back to me and I'll put my something that I did here back. So kind of just to give you a simple example, for example, sending money. Let's say you have an account on one shard, account on another shard, and you want to send money from shard A to shard B. So, in a simple one shard system, you would just subtract here, add there. If anything failed, like subtraction failed or addition failed, you would just revert the whole state. Here, you actually need to subtract first, finish this, send it to another shard, add there. Let's say that failed. You would then come back to the first shard and put the money back. So you kind of need to maintain this state where you move money out of one shard but didn't put it yet another, and need to handle those callbacks. So it's a little bit more complex, but it's allows to scale, right? Because you can now send 10,000 of those mails to a bunch of other applications, and they will be executed later. So this is kind of allows you to scale up your applications as well, instead of having a limit on how much you can do in one block. So, as I mentioned, pretty much we use TypeScript, which is a programming language. Now, TypeScript, like the full TypeScript doesn't actually compile to WebAssembly, but there is a compiler called AssemblyScript, which is growing with the functionality day over day, but still missing a lot of functionality right now. But the kind of target is to have as close to TypeScript experience as possible. Specifically, you should be able to copy paste some JavaScript, add some types, and get it running. So that's kind of what we're targeting after. And of course, we're building a library that first of all, gives you access to all the standard tools that you want, like hashes, encryption, secure randomness, all those things are provided, and then we'll kind of keep enhancing this type of stuff as we go with what is like depending on feedback of what is missing. So please give us feedback. Now, what is DevNet, right? DevNet pretty much is just a node you can run. So, for example, it's all Rust, so it's pretty easy to install and run. We have documentation how to do it. But for today specifically, I just will show you how on a version that we have hosted already on our server. And the idea here is that when you're starting building, you don't really care that even if we are malicious, you can still build it Rust and check if it runs. And then when you do want to you build something that you don't want to expose right now or don't trust us, then you can just get the code, get the studio, run it locally, develop things like that. So on top of this, of course, it's not about just building a backend smart contract. You also want to make sure you have a front end, right? So you actually have users. And so we build pretty much SDK in JavaScript. So it's very similar to ETH.js kind of API with some additional stuff. And the idea is it pretty much can access your PC to the node, or it can send transactions to the network. It provides you kind of wallet and account abstractions. And we have a few interesting things which I'll show and kind of walk through as I'll be showing. And of course, it's available on NPM, CDN, so you don't need to deal with a lot of stuff. All right, so let's jump into Studio. So as I said, we believe into developer experience. So we want to make sure as a developer you can pretty much jump into development the first second you got there, right? So studio.nearprotocol.com, this is our IDE. The first thing you see is selecting a template. So you can select one of the pre-existing templates of the projects. So in this case, it will be a guest book. So very similar to chat. And this is more for examples, not for real kind of applications. So main.ts is where the main source code is. And as you see, it's pretty much a, if you guys familiar with JavaScript, pretty much JavaScript, and it has types in all the places where you would expect to define types. So export function is pretty much where you define a function that you can call externally through transactions. So in this case, add message is a function that you can call. Externally, there's a parameter text or a string. So this function just adds a message to the storage of this contract. And the way it's done is uses global storage, which is the key value storage you have. You have a few helper methods to get pretty much U64, or get bytes, set bytes. So you get this current number of messages. You create a message. You post the text and the sender. So it gives the current sender of the transaction. And then you set bytes with this message into the global storage. And then you use the prefix of the ID just so you can actually order them and get last 10, or last whatever. And you pretty much increase the ID. So this is kind of like pretty much an index into the database that we do. And our plan is to build like an ORM type of thing on top of this, but this is still in progress. So ideally, you should be able to just create a new class like this and then say like a commit to the database or like get by ID or filter all of the messages that match some criteria. So then the other method we have is get messages. So this returns you kind of last 10 messages. So returns an array of this posted message. And logic here is just go over the index and get bytes of the messages. So that's pretty simple, 30-line contract or 60-line contract. Now, the first thing as a developer you want is to test that this stuff works. So we already have here a testing integrated. So what this allows to do is test.js is a file that gets executed when you run a test. And you pretty much set up contract. So in this case, we just get whatever the current contract is, we load this contract, and we define which methods we have, which one we want to use. And then you can write very simple unit tests, right? Just by calling contract.getMessage with whatever arguments and check the results. So it's very simple. In JavaScript, you can right away test your application. And what this does is pretty much deploys this app, compiles a contract, deploys it to DevNet, spins up front end with Jasmine, which is a testing framework for JavaScript, and runs its tests in it and shows you the results. So, like super simple, going from I have a contract, I want to test it, run it, get deployed. If there's any errors in compilation, it gets the output here. And if there's any problems with tests, you can explore here, kind of go into more detail, and pretty much, make sure your application works. Now, you can also explore, what it compiled to, etc. Now, the more interesting stuff is you actually want to build a front end for this, right? Because what is an app that doesn't have front end? Now here, it's a little bit more complicated. I mean, this is like, I'll show you in a second how it works. But the idea is you want to, when you run, it just deploys an app to the DevNet, spins up a front end served right now in our, we have NEAR pages, similar to GitHub pages, for static content. And you can always, serve it from somewhere else or set up another way of serving front end. But what this does is pretty much integrates the other part, which is we call it iframe wallet. So the idea is that as a user, when you just came into this, you don't really need to know about the keys, you don't really need to know about how to interact with these applications, but you really want to first get some value out of this application. And our assumption is that, like, if you don't have already a wallet installed in the system, right? You don't have like a hardware wallet, software wallet, extension, then we can just provide you with what we call iframe wallet. So what the iframe wallet is we still store your keys in your browser in local storage, but the code that interacts with it is loaded from our website. So it's loaded from wallet.nearprotocol.com. And here, if you're using this flow, it is you trusting pretty much us to not inject any malicious code there. So this should be used only for like kind of beginners in the blockchain world. But what this allows to do is pretty much build a very nice flow, which says like if you already have an account, it will log in. If not, you can create an account. And then what it says is like you can authorize this specific app that we came from for your account to use pretty much just submit transactions. And here we can add more control, which says you can only spend this much money, you can only spend this much network fees, etc. So now this application knows who you are, but it doesn't know your keys. It doesn't have access to your keys. What it is there's an iframe on this page, which pretty much is served with our JavaScript, which has access to keys, and only that iframe can sign, and the application cannot access to this. There's a caveat which just only works for, it doesn't work for Safari, but we're working on kind of fixing that. So now you can, just post messages here, and if I share like this link, which is kind of hard to see here, you can actually, I can share it with you guys, and you can start interacting here as well, right? You can actually go through this flow and start interacting with this platform. So if you want to try it out. Now, what kind of blockchain if you cannot see the blocks, right? So we have a block explorer, and it ignores the quality of the UI right now. We're working on it. So here you can actually see that I, with this account, send this method with these arguments. It was included in the block 82, and in this case there's not much other transaction going on. But you can kind of explore what's happening here and like see when we deployed a contract, for example, like created an account for SASD when we went to wallet. In this case, Alice created this account. So you can kind of see the progress as a network and do some debugging here. Specifically because what happens is when you submit a transaction, there's actually these receipts, cross-shard transactions created, even though right now there's one shard here, and you can kind of see the status of these things happening throughout. Of course, there's a lot of like other stuff happening to make sure, like, if you turn on, you can see logs of transactions and you send transactions, etc. So just making this experience really smooth and easy to use. All right. So just to kind of go over another example. So let's build a ERC20, right? So who's here familiar with ERC20? Alright, so for people who are not, ERC20 is pretty much a definition of how other tokens must be built on the Ethereum ecosystem, such that all of the other applications can use them. And what it is pretty much just a few methods and kind of describing the logic of this method, right? So let's say we want to build, our own Dogecoin on NEAR, right? Specifically, we want to make sure, how much total supply is there. We want to check balance of other accounts, and we want to transfer money. There's a few more things, but it's kind of the main one. So here, we would write just total supply. We have a constructor method, which we're gonna polish a little bit, but the idea right now, when you initialize, you just put everything to the initial owner. In this case, like if you want it to be yourself, you can always just hard code here as the account name, or you can have a Dart or whatever. And then, so total supply just returns this constant, which is how much total tokens we have in our, let's call it cat coin. And then you can say balance off or the current owner. So what this is just you go to global storage, you get an item with a specific key, and then if it's empty, you just return 0, right? So keys here, because we want to maybe have more stuff, we just prefix them with balances. So the key here is address plus prefix balances. And then kind of the main important function, right, in any token is transferring token between people. So here you have the tokens from key to key. You get how much tokens we have. So this is a little bit older version where we only had strings, but right now you can actually pass integers as well, and you don't need to parse them. And then the main thing here is that you do an assert. So you check if the balance of this current account actually has enough money for transferring this many tokens. And if not, it will actually issue an error. And if it is, then you just subtract the money from one account, add it to another account, and return true. So very easy. So in this case, kind of the example UI here is nothing, because very much you should be using this from the wallet. But kind of for just as we're all developers here, here's an example of how you use it, like if you were building your own wallet, right? So what you would start with is you would initialize the account with, in this case, what is my developer account, kind of created by Studio. So whenever you open Studio, you just create a developer account for you. And what this does is pretty much it's sends a transaction and monitors the state of this transaction, and it prints all the logs here, so you can kind of see what's happening with the transaction. And of course, you can take the promise of this and pretty much react on completion or failure of this thing. Now, if you want to check, for example, balance, of this account that it actually got all the money, you will get as a result of the promise the million tokens that we created, right? And then the last thing we can do is transfer money to Bob, right? Or to anybody else. So here, you pretty much just call the transfer method. This is exactly the methods, we actually just described here. So you see it's pending, and then, transfer, balances, pending. Something may go. But what I wanted to show is that if you send too much, it gets rejected. So you can actually react and narrate here. And of course you get a nice not enough tokens in account, in which file name, line, and you get as it returns an error, if you don't catch it, it actually shows you in the log. So this is, follows this not enough tokens in account. So it kind of surfaces back to developer in a nice way. In the future, because it's WebAssembly, you can actually hook in debugger from the browser through the WebAssembly code. We haven't done it yet because it requires actually emulating some of the runtime inside the browser, but that's actually terrific. It actually will be able to step through this code as well and keep out the state of the transactions. All right. So pretty much there's docs with some of the tutorials and API docs where you can kind of learn how to use all these tools. They're still in a bit of nascent state, but we're working on it to kind of keep expanding. We would love help with that. Do you guys have any suggestions of what you want to build for a quick workshop? Market. All right. Non-fungible token. All right. So we already have a fungible token here. Let's build a non-fungible token. So let's say we want a function which pretty much creates new token. Creates new zombie, for example, is a DNA. So what you want is you want to store. Yeah. All right. I'll be just talking. Speak loudly. Yeah. So what we want is to get a few things. We want a class that will represent our token, right? So in this case, it will be let's make a zombie. I guess we know the script of zombies. All right. So if class zombie, we want DNA and owner. And I guess I have level, but can add it later. So just to kind of show you an example how to do like this external objects. Pretty much, you say export class. What this does is gonna those exported kind of in TypeScript, and what it will also create a wrapper to serialize the serialized object as well. Sorry. pretty much we do some code generation on the side. Sadly, we did not fix that yet. So right now, if you're adding a new file, you kind of need to add a new binding into the gulf file. The gulf file is like way you compile JavaScript in general the things. So actually, we'll just use this example. But yeah, the idea is you just need to add like compilation of this file, planning to automate that a little bit more. So let's say we have zombie, it has DNA and owner. And then from model, we get zombie. So it's model.near, this compiled version. So then, let's say, create zombie, pass it DNA. So one thing we can check is that there's no already zombie with this DNA exists, right? Just to make sure.
Is it similar to what you would do in Solidity with require?
Require for what, sir?
In Solidity, require.
Oh, you mean for the asserts?
Yeah, I mean in the smart contract when you would require.
Oh, to import as a file.
Yeah.
So it's somewhat similar.
To do the check, yeah.
Okay, so we got the zombie. We checked that zombie doesn't exist. Now we create a new zombie. This new zombie has owner as the current person, and DNA as the DNA past, and we just store. We just keep by DNA, and we serialize this. So you can, if you want, you can choose your own serialization. This is just default serialization that is attached to objects. Probably something. So, as I said, the great thing about all this is we should write tests. Specifically, we have the zombie. No view methods yet. So we can just await on the contract, create zombie. Pass it the DNA. And let's add a method that gets a zombie. So we can check if it landed on the blockchain. So this is just a view function, right? Get zombie, which returns to us a string depending on the DNA. So here we just do this and probably messed up somewhere here. Because Python is still in the brain. Alright, So we're just at the view function, right? So view functions is the functions that don't change the state, and which means you don't need to call to create a transaction to call them. So signal validity. It also will fail if you do call a function that does change the state, and we'll tell you about that, which is nice. So then, yeah, you just say, okay, comes zombie, wait, contract, zombie, this DNA test. Let's just see. So calculation did succeed. As always, that demos. So we can just return serialized. Or we can return the code. So what happened? Notice exists such DNA. Okay. So search and boom. So we got pretty much now my unit test says that I don't expect something. Oh yeah, so this idea, you actually got a zombie who's on their DNA. So if you want to add, a transfer function, so you say to DNA, this function that transfers, we can look up the zombie first. DNA, assert, zombie, not equal now. Zombie does not exist. And then also assert that zombie owner is equal to current owner. Zombie does not view. Then is that all correct? Then we can just swap the zombie's owner to 2 and update local storage. So here's the transfer of the token from one person to another. Get it, check stuff, send it back. And again, we can now go check, write a unit test, it transfers it, checks it, all goes back, and it's fast. And if you want to keep adding stuff, this kind of thing. Any questions? This kind of stuff?
Do you guys have I don't know, like a medium area that you guys are showing some of these examples, or?
Yeah, so we have, we're getting tutorials ready. So there's a tutorial for a smart contract, which kind of explains a bunch of stuff. It also has this game, which is we call it NEAR Place, which is, if you guys are familiar with Reddit Place, there's a game where you can put pixels on a thing, and a bunch of people can play together. So this is an example if I could build it on a blockchain, multiple users collaborating in one I'm also, this is not finished, but like how to like so information to function. And we're gonna keep adding stuff here. And there's also, I mean, always, basics, quick start to kind of how to write, how to use, how to run things, etc. Interactive, and there's APIs for the lib and for the smart contracts. But yeah, I mean, this is still in works, but any feedback you give us, something missing, that will be very appreciated. Well, I mean, it's pretty much what I have. I can answer pretty much any other questions if you guys are interested about protocol, about.
I have a question.
Yeah.
So I was just looking at your website and it talked about alpha in February. Is that still the schedule?
It is in schedule, but maybe as a result of development, maybe a little bit postponed. But I mean, so like we have it in very, very raw state right now. Like you can actually go and run multiple nodes together and send transactions, start consensus. As I said, it's all open source. Like pretty much, the idea is, by the end of February we should have a somewhat solid version, but may take a few more weeks to stabilize it from there. But yeah.
So are you still kind of on schedule for MainNet mid-year, or is that looking more like the end of the year?
I think, I mean, our current plan is July. So,
For BuIDLNet, you mentioned that would entail governance. Can you speak a little of like how that would function, what that means?
sure. So the way we want to do governance is pretty much have 3 layers. So one layer is kind of general voting. So if there's a proposal and 66% of people voted on it, or 66% of stake, like of tokens voted on something, that should be, done. And the point here mostly is that if 66% of people want something, they could just go and start producing their own blockchain anyway, because this is a percentage like at which they can start producing their own blocks. There's regarding another 60%. So this is more of a fail-safe than, like, I don't expect there will be a lot of participation in this like real on-chain voting systems. Now, the kind of second thing is a foundation as board. So the idea would be to get people who are involved in the protocol, who are developers, influencers, scientists, kind of people who grow communities locally, get them together, and then pretty much decide on kind of, depending what they hear from other stakeholders as well, where the protocol should evolve, right? So this is kind of a board, or I call it a congress. And then the final piece is I call it benevolent maintainer for now. So what it is a company that is, somewhat centralized, which does development of the protocol, which continues pretty much evolving. And I think this is a very important part. It's like there should be somebody who is responsible on execution. So it's like executive branch. And the idea is that they can propose new changes, and then Congress can say, no, this is wrong, or it's good. So you have like this kind of accountability there. And until this company is doing work that pretty much improves the protocol, they can keep doing that. And if they hack or became malicious or in general kind of not aligned anymore with the community, then this company can be fired and a new maintainer can be found. But there always should be somebody who's like responsible for execution, right? So that's kind of a general thing, and then like the details still being filled out, like how exactly like the mechanics for election, for example, for the board should be done from the community, because there's a lot of like interested parties, how you can actually present them in meaningful ways. There's a lot of research and like political science about this, so we can look into that.
Cool.
Also about the governance, also native token. I think you didn't mention any native token. So do you plan to have native token, or the idea is that network should be totally token agnostic? Again, for governance, it should be there. Do you plan to have a governance token? Or how this community that decides should be like decided.
Yeah, so there is a native token, a NEAR token. And yeah, so that economy is where pretty much the kind of this economic parts of it coming from. So specifically, so it's a native token, it is what you stake. So it is what you say, hey, you know, here's 10 tokens, I want to do validation, tell me when and how should I be doing this. And if I do something wrong, you can take these tokens. That's pretty much the staking part. And then holding these tokens is what provides you bandwidth of this network, or at least some credits for this bandwidth. And this is also the representative power for the voting in this community.
So native token is government.
Yeah, native token is governance token, yeah. And staking token, like security token and, you know, like pricing token for the operation of the network. Like the way kind of to think of it, like as I said, it's like a community operated cloud. So the people who operate it are kind of shareholders of the system, right? And the people who use it are shareholders of the system, and they kind of interact with this together.
Where does your VM come from? Did you guys write it from scratch?
No, so we, as of a week ago, we're using Plasma. So this is implementation by some folks in San Francisco. It is, you know, deterministic, floats are turned off, which is the only non-deterministic part. And then we're injecting gas things. We are talking with the Wasm team to see what they kind of come up with. We were using parity implementation before, but switching to Wasmer gave us 100x boost. So 100x faster than parity at the moment.
Is that faster? I haven't heard of that. Is it used by another blockchain?
I don't think so. It's written in Rust, which only like a few teams right now care about. So like, you know, the OS, for example, uses C++ implementation. But like we believe Rust is way more stable code in general. But it uses crank lift, I think, gym stuff. So that's where the speed comes from. Because what parity uses right now is interpreter, which is super slow.
Will you be building on this weekend?
So I'm actually judging. So, but if you guys are interested, please do. It is like we're actually having internal team hackathon back in San Francisco on Thursday. And you know, if you guys are interested, like please let me know.
Have you done hackathons before? Or?
We've done internal hackathons, and like a few external people are building it right now. They're kind of in our community, but we haven't done like full-on hackathons yet.
Okay. Do people usually stay up all night working on the tools from what you know? Or do they, what's the best strategy in your opinion for a hackathon?
That's an interesting offshoot question, but okay. I mean, it depends on your energy level a lot. Like I was in ESSF hacking, and I did not have energy to stay up all night. That's some of my colleagues did, and you know, so it's a question of like energy, like mental preparedness for that. My recommendation is to build on something that is easy to build on. You know,
This, like you would say this?
This is, you know, one of the options you can consider. Yeah. I'm a little bit biased here, but yeah.
I want to learn one or two new things in a hackathon. Actually, a related question. Do you have any other like side projects, not your projects, that trying to build DApps or smart contracts on DevNet right now?
Yeah, so we have like, I think 5 teams trying it out right now.
You said DApp?
DApps. I said DApps.
What?
I said DApps, not DApps.
Okay.
But DAO is also
No DAOs yet.
question,
Yeah, no DAOs yet, but yeah, this team's trying it out right now. But yeah, so, you know, if you guys are interested to learn more about sharding, we have a ton of content on our Medium. We are starting to kind of talk more about business models and kind of about how to build this ecosystem in general, which I think is very important because like part of the story is what is this, like decentralized finance is fun, but there's like more about the story like Web3, but currently it's not very explored. So it's a super interesting topic, and if you guys are interested to talk about it, please let me know. Join our Discord, NEAR.chat, super easy. And please leave some feedback about Lowe's presentation and like what you guys building and what's interesting to you.